We are Group 3, and this is our presentation on sea level rise. Sea level rise is defined as an increase in the world's oceans due to the effects of global warming. This comes in three main ways. The first is melting ice sheets in Antarctica and Greenland. National Geographic claims that Antarctica and Greenland contain 68% of the world's freshwater supply. As temperatures around the world increase, the ice here melts and adds to the level of the oceans. However, NASA claims that this only accounts for around a third of the total sea level rise. Similarly, another third is caused by melting glaciers on top of mountains. These glaciers form when snow condenses into ice at high altitudes, over hundreds of years. NASA claims that this accounts for a disproportionately large effect on sea levels, as these glaciers only account for 1% of the total freshwater supply on Earth, but more than a third of the total sea level rise. A final third is caused by the thermal expansion of water. In April Reese, a researcher with a master's degree in environmental studies from Yale University, claims that 90% of the heat that reaches the ocean is absorbed. As water absorbs heat, it expands, which adds to the level of the oceans. So sea level rise poses a dangerous threat to hundreds of millions of people around the world. According to Sonia A. Carlson from the University of Sussex, 630 million people could be below sea level by 2100. This is a drastic increase from the 187 million people in 2011. Sea level rise also harms the coastal ecosystems like wetlands, mangrove forests, and salt marshes that protect cities from storm surges and flooding. Another threat that sea level rise causes is to the economies of coastal population centers. Research from the East Carolina University shows that housing prices lower as an effect of sea level rise because people don't want to be living in areas that are threatened by flooding. Sea level rise also harms the economies of coastal areas by harming the tourism industry through removing beaches and harming local businesses. A final threat that sea level rise causes is the cultural heritage of countries on islands. Some islands in the Pacific are at risk of being completely submerged by sea level rise, which would include all of their cultural heritage sites being submerged. With all this information, we decided to come up with two solutions for sea level rise. However, because of the effect of thermal inertia, sea level rise will continue even after all carbon emissions are stopped. Because of this, our solutions are to mitigate the effects of sea level rise and not as a permanent solution.
Our first solution that we present is living shorelines, which, as the name suggests, are a way of reducing damage done by waves and flooding by planting vegetation or through other natural methods. One example, which is shown in this picture, is in the Trinity Center in North Carolina, which was going through a lot of erosion done by waves, but the North Carolina Coastal Federation and the National Oceanic and Atmospheric Administration helped plant smooth cordgrass and placed bags of oyster shells, which helped not only reduce the erosion caused by the waves, but it also provided a habitat for different organisms, and it even improved the water quality. One advantage of living shorelines is that not only do they reduce the flooding in the area, but rather than pushing the waves away, which is what seawalls and artificial barriers do, they actually absorb the wave energy. Another advantage, according to Lexia Weaver, who's a coastal scientist in North Carolina, is while living shorelines can cost as little as $75 per foot, seawalls and bulkheads normally cost $250 to $450 per foot. However, living shorelines also have their disadvantages. One major disadvantage, according to the National Oceanic and Atmospheric Administration, is that they require a bit of replanting and maintenance after initially being set up, which can be a bit of a challenge, but after time goes by, they become more resilient to waves. Additionally, living shorelines are not suitable for all sites, meaning that if a site has too high of a wave energy, it might not be suitable. This shows how more natural methods, such as living shorelines, are more effective for low to moderate wave energies, while bulkheads and revetments, which are the more artificial techniques, are better for places that have strong waves or places that already have implemented these solutions.
A seawall is an enormous construction made out of mostly steel and concrete. It would have to be incredibly strong. It would have to hold hundreds of thousands of gallons of water to keep the sea away from the areas at risk of sea level rise. It would also have to be relatively cheap due to how expensive seawalls can be and how big they would have to be to cover all of the areas that would be at risk. Seawalls are very effective at what they do. They absorb wave energy and keep coastal areas that are at risk of sea level rise very safe. This is good because a seawall is very simple. It's putting up a wall made out of relatively strong materials between the places where people need to be and the ocean. This can disrupt systems like beaches and beach ecosystems, both human and animal, and this is a lot of the issue. Another issue is the cost. Seawalls would be extremely expensive, as just covering Miami would cost $3.2 billion, says Molly Minta, an author on the subject. Caitlin Sullivan, a climate scientist and journalist, says that a good seawall could cost upwards of $400 billion. And the biggest problem with seawalls, however, is the fact that they are temporary. A seawall will require constant maintenance and repairs and upgrades to keep up with the rate at which the sea would be rising. And this is what keeps them from not being the best solution of the two.
In conclusion, sea level rise is an extremely relevant and important issue because as the temperature increases from global warming, issues will only get worse. We had two solutions, seawalls and living shorelines. We decided that living shorelines were the best solution because they are more cost-effective, sustainable, and environmentally friendly, and won't degrade the beaches that they are located on. Sea level rise will continue to have negative effects around the world until the solution and others like it are implemented.
Thanks, guys. Okay, so I got a few questions for you, and just as you're standing, you'll be student 1, 2, 3, and 4. Okay, we'll start at student 1. So student 1, how did the group decide to include or exclude student 2's perspective from what we just saw? So what part did student 2's IRR play in that presentation?
Yeah, so Anthony's perspective was through an environmental lens. So he was talking about how sea level rise would hurt habitats in different areas and hurt ecosystems. And I use that in living shorelines by showing how they don't hurt the ecosystems around them as much as seawalls do. And Will Clemmer also used Anthony's perspective in seawalls by talking about some of the consequences of seawalls on local ecosystems.
Okay, terrific. Student 2, reflecting on all of your colleagues' work, which one had the greatest impact on your understanding of the problem? And it could even be your own work, but which IR do you think clarified the problem the best?
Okay, so I think that Tyler's essay was the best for this because he did the futuristic one, which really helped us when making our presentation and understanding the problem. Because knowing how it affects the future and what we need to do to solve the problem is a key part of forming our solutions. And as we formed the solutions, it was really critical for us to understand what the problem actually was.
Okay, terrific, excellent. Moving on to student 3, what's a way in which your team's resolution makes you think differently about your own research? So,
Personally,
like your own IR.
my research was not heavily in favor of seawalls, but I was still under the impression that they were a generally good idea to employ in most areas, which is the reason I chose them. But Oliver's research and Tyler's research both showed me similar of the downsides, as well as Anthony's research. And that helped me even out a bit more on have a less biased perspective on seawalls.
Okay, excellent. And then finally, student 4. Describe an argument from one of your peers' reports that didn't make it in, but still left an impression on you. So like something that they said that really didn't form any part of your final presentation.
Could it be my own argument? Or?
Could be, yeah.
Yeah, I did an argument around geoengineering with aerosols, which
the idea was that it was a futuristic lens because I was doing the futuristic one, and the idea was that you would spray aerosols into the atmosphere, which would deflect some of the sun's rays and energy, and therefore it would stop global warming and therefore sea level rise relatively quickly. But it would have to be repeated on a yearly process, and it would have certain environmental effects that would be negative. And the reason that that didn't actually make it into the overall presentation is because it was actually addressing global warming and not actually sea level rise. So it was kind of a, if we do this, then eventually it'll stop sea level rise. And
Cool. Okay, thanks guys. Nice job.